starting with nuclear fission. Okay, and nuclear fission is basically the process through which a heavy nucleus splits up into lighter nuclei. Okay, so it's the process by which a heavy nucleus splits up into lighter nuclei, and in this process some energy is also released. Okay, so an example that we can look of this is the fission reaction for, let's say, uranium. Okay, so if you have one neutrino particle, so that's neutrino, and you have this uranium atom or nucleus, sorry. So you have this uranium nucleus. Okay, this will collide with the uranium um, nucleus, and it will lead to a series of reactions. So first, you get the uranium nucleus looks like this. Okay, so you can see that you've had a neutron that's been added to the nucleus, right? Now this neutron decays radioactively, and it splits into two different nuclei of two different elements. You have this one, barium, and you also have krypton. Okay, and you also have three uh, neutrinos that are being released, neutrons that are being released. Okay, so the production of neutrons. So this element over here, it's a neutron. Right, the production this symbol represents a neutron. Sorry, the production of neutrons is basically a feature of fission reactions, and this reaction. So you can see that this reaction, it's going to. So the reason this reaction started was because of a neutron, right? And this is the first step, then this is the second step. And you can see at the end of this reaction, it's producing three more neutrons, right? So these neutrons that it's producing can then go back into the start of the equation, and they're going to react with more uranium to produce more of these elements, right? So this is going to produce this reaction, we can say it's self-sustaining, right? Because as long as you have enough uranium, right, it's going to keep on producing neutrons that will keep on reacting with the uranium, and then it will produce more neutrons and so on, okay, until the uranium gets finished up. So we can say that this reaction is thus self-sustaining. Okay, so this reaction it produces neutrons, okay, is self-sustaining because of this. And we can say that this type of reaction, you can say that it's a chain reaction because of this. Okay, the chain reaction keeps on going. You need a certain minimum mass of uranium in order to have this work. Because if that minimum mass is not present, then the neutrons will just escape and they won't react with the uranium. Okay, so you need a certain minimum mass to get it going, and that's known as a critical mass. Okay, a critical mass, okay, of uranium is needed. The energy that's released, um, we can see is you have to first figure out what the differences in the mass is. Okay, so the difference in mass of the reactants versus the difference in mass of the products. Okay, so if you work this out, I'm going to, you look at this equation, right? You're going to add together the masses of each of these, and you're going to subtract them from the masses of these. And if you work this out, delta M, that's the difference in mass. That's going to be, I'm just going to write it out then, I guess. 236.0526 minus, and you get 143.92292 U plus 88.91781 U plus, and then you have three neutrons that were being released, so you have to multiply their mass by 3.8665 U. Okay, and once you subtract it, you get this mass difference, 0.18587.5 U. Okay, so the energy that's going to be released, because this mass is, this mass can't just disappear, it's converted into energy. So the energy Q equals the difference in mass times c square. And we saw in the last class that you can write this in terms of mega electron volts. So in terms of that, it would be 1.85875, the mass times 931.5. Okay, and this is going to be approximately equal to 173 mega electron volts. Okay, so we see that fission is an induced process. Okay, so one more thing is fission is induced. Okay, so it requires that initial reaction with the neutron. Okay, requires initial collision of neutron. Okay, spontaneous fission is possible, but it's very rare. Okay, and this energy, so this is basically the same way. So if you look at all of this, this fission is basically the way that nuclear power plants work. Okay, and also something like this also happens in atomic bombs or nuclear bombs, right? So you have uranium in your nuclear power plant, and you collide it with a neutron in a controlled way, and that causes a cascade of reactions, right? So it causes a chain reaction where each uranium atom decays, it produces more neutrons, and those neutrons react with uranium again, and so on and so on, right? So the reaction keeps going, and it keeps releasing more and more energy. So if we do this in a controlled way, you can create electricity. If you do this in a not so controlled way, right, if you then you can create basically bombs as well. Right, so I'm going to give you a question. Do you have any questions for this?
No, I don't.
Right.